This is a video about Project Cronus. It's basically a digital clock I made for my nightstand that only uses logic gates on this FPGA that I bought. The reason why I did is because I needed a clock for my nightstand, and I had never really worked with FPGAs before, so I wanted to see if I could, and if I could do the added challenge of only using logic gates to build it. That didn't happen. It would turn out to be pretty hard and really tricky at parts. But let's just move on and get into some of the pieces I used. This is a DS3231. It's an RTC, or real-time clock. It's very accurate. It only loses about a minute a year, so that's pretty good. Then I have this really big 7-segment display. It's red, so it doesn't mess with the circadian rhythm while it's on all night. And then lastly here I have the FPGA. This is a tiny FPGA-BX. It's pretty easy to use, lots of resources. I highly recommend this one if you are just getting into FPGAs or field programmable gate arrays. Yeah. Let me get into the how I built this. First off, I used a bunch of JK flip-flops inside the FPGA. JK flip-flop is just 2 AND gates and 2 NOR gates, but I could not get it to work like this through the programming language, Verilog. That's what you use to program FPGAs. So what I did is made this kind of hacky solution, and honestly the only thing I really need is right here, titled the money. Basically how a JK flip-flop helps out as a counter is when these two signals, the J and the K, are both 1 or tied high, the Q input will invert every time there's a clock signal. So what this ends up causing is a divide by 2 counter, and if you string up a bunch of them, you get divide by 4, divide by 8, 16, and some other numbers, I'm sure. But the way I used them is to make counters, 6-bit, 6-bit, and 4-bit counters to count the seconds, minutes, and hours. So taking the one of the signals from the DS3231, putting into a 15-bit counter, putting that into a 6-bit counter to track seconds, another 6-bit counter to track minutes, and then from there a 4-bit counter to track hours. This all together helped me keep track of time. What's special about this though is 2 things. One, they need to be reset, so I needed special reset circuits or little checks to see when these hit to 60 and when this hit to 12 that these would reset. But then I also needed a decoder, which would turn the 1s and 0s of this 6-bit counter and this 4-bit counter into the 1s and 0s to turn on and off the different parts of these 7-segment displays. Together they all get into the display here, taking in the second marker or the colon and this AM/PM marker to your eyeball, which helps you see what time it is. So to build it, I took all of these components and designed them in the FPGA through this code that I'm hopefully showing on the screen right now. And then I took what mostly was the buttons and the drivers for the 7-segment display and put them onto these circuit boards using Eagle, and then I got them printed by OSHPark. The problem is these FPGAs, they got pretty weak signal out, so they won't be able to turn on and off these LEDs as well. So I put some transistors and resistors and stuff to make them control these lights on the screen much better. The thing is, I ended up taking up most of the boards. Actually, I think the majority of everything on these boards is just transistors and resistors. You can see that better here. This is the completed board right here. And then also we've got these buttons, like I mentioned earlier. They're for setting the time. Here we have the other board. Also, I had high hopes to build an auto brightness circuit here, where we kind of get brighter during the day and dimmer at night, but that didn't happen because I couldn't get it to work. I could barely get the potentiometer to work. Basically, this was an exercise in compromise because I couldn't get a lot of the things to work. pure logic gates, auto brightness. None of that really went as I wanted it to. But put together here, if we plug it in, we can see it's working. Hopefully you can see on the camera, but I can change the hour. Once it rolls over to 12, there's a little light here for the PM, and then I can also change the minutes as well. All together, works pretty well. Tells the time. The only weird caveat is whenever a number has a lot of segments on, it gets dimmer. You can probably tell that pretty easily by the 1 being much dimmer than the 3 here in this 13. But other than that, worked out pretty well. Tells the time, nice big numbers so I can see it from across the room. I enjoy it. I was thinking about putting a case on it, but I think it'd be better to leave it open because it looks really cool. Oh, also, I taped on some cellophane from some binder dividers. These red filters help the red numbers pop more. I would show you the other way, but it was a pain to get on, so they're staying like this. Anyway, thanks for watching. Hopefully this video wasn't too crappy.